Alright guys, welcome to Math 0314, section 5.5, solving rational equations. Y'all know what to do here when you see these situations. Don't get intimidated by the fractions. We know the goal is always initially to get rid of the fractions as soon as possible. So when I say 2, 3, and 4, my response is to multiply through by the number that's going to get rid of 2, 3, and 4. And that number is going to be 12. In other words, the LCM of 2, 3, and 4 is 12. 12 is the smallest number that will get rid of 2, 3, and 4. One other note about this is that if you can't immediately see that 12 is the smallest, you can just always multiply by all the numbers. So notice if I multiply 2 by 3, I'm going to get 6. 6 times 4 is 24. While that's bigger than 12, it will still work because all the numbers can divide through by 24. It's just your result will be a larger number. So if you can't find the LCM, don't stress over it. Just multiply by all the denominators and you will get a value that will work. Okay, so I'm going to distribute 12 into everything. So I'm going to have 12 times 1/2 x plus 12 times 1/3 equals 12 times 1/4 x. So moving right along, 2 goes into 12 6 times, leaves me with 6x. 3 goes into 12, gives me 4. And 4 goes into 12 and gives me 3x. From here, it's a simple problem. We just now want to combine like terms, so we'll put our 6x's together. And I'll get 4 equals negative 3x. Finishing off, I'll divide through by negative 3. And x is equal to negative 4/3. So, though these problems as we progress will seem intimidating, the process is essentially the process we've always been doing. Get rid of the fractions as soon as possible. Let's take another look. So here we have an interesting situation because we have the denominators to be 5x and 3. So what I'm going to do is I'm going to multiply by 15x, distribute 15x into every part of the equation, distribute 15x with every term, and this will give me 15x times 3/5 plus 15x times 1 over x equals 15x times 2 over 3. Now from here, we can see why we multiplied by 15x. 5 goes into 15 3 times, so I'm left with 3x times 3. Here, the x's will divide out, and I'll be left with 15 times 1, which is 15. I'm going to write it as 15 times 1. The 3's are going to divide out with 15, and I'm going to be left with 5. So I'm left with 5x times 2. Now, the next move is we're going to multiply 3 by 3. We're going to get 9x. Multiply by 15. And here we're going to do 5 times 2 is 10x. Now all we got to do is finish the problem off. Subtract 9x from both sides. 15 is equal to x, and there's my answer. One extra caveat that we need to be sure of is take note that if you get something in the denominator that is you can't divide by, specifically 0, if the x was equal to 0, then the answer would be no solution. So you have to actually take your value and substitute it back in and make sure that you do not get something that is not part of the problem. In other words, when this problem initially started, we can say that this is true as long as x does not equal to 0, right? That's a stipulation. So if my final result, I ended up getting x to be 0, then I would have a problem. I don't here, obviously, so I don't have an issue, and I have the problem correct. I can move on. Alright, so here's another situation that, again, perhaps in first look looks intimidating, but all I have to do is multiply through by the denominator, which is w plus 1. Alright, so we're going to take w plus 1, we're going to distribute into all of these. We're going to get w plus 1 times 3 minus w plus 1 times 6w over w plus 1 equals w plus 1 times 6 times w plus 1. Alright, so why do we do this, of course? So that the w plus 1's will cancel out. Distribute this here. I'll get 3w plus 3 minus 6w equals 6. Combine like terms. Negative 3w plus 3 equals 6. And from here, subtract 3. We'll get negative 3w equals 3 multiplied through by negative 3, and w is negative 1. So, as you can see, all we did was we multiplied through by w so that we could get an equation like such that is very easy to solve. Okay. Now, very important, like I said in the previous video, I do not want you just to walk away from this thinking, oh, look, I'm done, I got w equals negative 1. It's very important that you check that when w is negative 1, that it's true. And as we can see here, it's not true. And hence, there is no solution here. So if you did not check, you would miss the question. Be very careful with that. Moving right along. Here we have 1 plus 3 over x equals 28 over x squared. And the approach again is the same. We're going to multiply through by the number or the value that will get rid of all the denominators, and this would be x squared. So this would end up giving me, when I distribute, I would get x squared plus x squared times 3 over x equals x squared times 28 over x squared. Once more, we have that the x squared and x's will cancel out and leave me with 1x. And here both the x squareds will cancel out. So we're left with x squared plus 3x equals 28. I would subtract 28 to the other side, and I would get x squared plus 3x minus 28 equals 0. This would break down to x plus 7, x minus 4 is equal to 0. And now, because we're multiplying both of these and it's equal to 0, we can say x plus 7, either x plus 7 is 0, or x minus 4 equals 0, and x equals negative 7, and x equals 4. And these would be my solutions. And again, we check. The only stipulation is that x cannot be 0. Our solution is such that x does not equal 0, so we're good. Those are my answers. Alright, here we have more of the same. Right? Hopefully at this point you realize p squared minus 9 breaks down to p plus 3 times p minus 3. That's the difference of squares. So when I multiply through, I'm actually going to multiply through by p plus 3 times p minus 3, because that will get rid of both of these. It will get rid of p plus 3, and I'll have p plus 3 times p minus 3 on the far right, but that's okay. So let's go through and do that. So we will get p plus 3 times p minus 3 times 36 over, I'm going to write as p plus 3, p minus 3. This is going to equal to p plus 3 times p minus 3 times 2p over p plus 3 minus, now 1 times p plus 3 times p minus 3 is going to be 1, minus p plus 3 times p minus 3. Okay, so the p plus 3, p minus 3s are going to divide out. I'm going to be left with 36. P plus 3 will cancel out, and we'll get p minus 3 times 2p. And here we're going to end up, again, if I FOIL this out, I'm just going to get back to p squared minus 9, so this will just be p squared minus 9. Continuing the process, we can distribute here, and I'll get 2p squared minus 6p minus p squared plus 9 equals 36. And as I continue to clean this up, I can put my negative p squared and 2p squared together to get p squared minus 6p plus 9 equals 36. I'm going to subtract 36 to the other side. Now notice here, the way I'm going to do this, I can subtract this and I'll end up getting 36, 16 minus 9 is going to be 7, so 27. But what I like to think is that this is 1 times 9, and this is 4 times 9, so if I take 1 times 9 away from 4 times 9, I'm left with just 3 times 9, which is 27. It's a different way of thinking. If that helps you, use that. If not, don't worry about it. You can just subtract like normal. I'm going to factor this, so I look at 27 and I ask myself, what times what is 27? That's going to be 9 and 3. So if we solve p minus 9 equals 0, p plus 3 equals 0, and when I add 9 to the other side, I get p equals 9, and p equals negative 3. Again, don't just assume these are the answers. We need to go back through, and we need to see in the original problem, I cannot put a negative 3 or 3 because those would give me 0 in the denominator. And the same thing is true here. P plus 3 is just written twice. So negative 3 and 3 are not viable solutions. Here, negative 3 is a solution, so the answer is just going to be p equals 9. So what you could see on a test is they'll sometimes say like A is p equals 9, B is p equals negative 3, C, it'll be both, I'm running out of space here, but both 9 and negative 3, and D will be no solution. So you have to be very careful. Oops. There we go. You have to be very careful that you choose the appropriate answer choice, right? Because you could have done all the work correctly and then missed the question because you said it's both when it's just going to be p equals 9. So check, 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 check. Moving right along. This is trying to intimidate you by giving you letters instead of numbers, but the approach is still the same. So I sound like a broken record here, but I'm just going to multiply by m plus n on both sides, because that'll get rid of the m plus n there. So I didn't write down, but the question here is asking us technically to solve for little m. And I want you to note that I don't care what the problem is. My goal is always initially get rid of the fractions. Make your life easier by getting rid of the fractions. So from here, we're going to take this, and I'm going to distribute. We'll get Vm plus Vn equals MP. Then I'm going to subtract Vm from both sides. So Vn equals MP minus MV. I'm just switching it around so that the m's match up. And hopefully from that, you can see what the next move is, which is to factor out an m. And to finish this off, I'm going to divide by p minus v. I'm going to get Vn equals p minus v, which is m. And this is one of the biggest moves, this sort of, anytime you're trying to get variables isolated, you put them both on the same side and you factor it out. That is a very, very valuable skill you will be using in future math courses. So please get comfortable with that. All right. Right here, this is actually more of the same. This is actually the first problem that is actually a duplicate of the previous one. So I'm going to suggest that you pause the video now and rework this problem. So go ahead right now and pause the video and try to solve it on your own. Going to assume that you've done so. I apologize if you were starting to solve this, you would ask, what are you solving for? You're going to solve for x. I apologize for that. So let me restate that. Why don't you now pause the video again and solve for what you're looking for. Okay, going to assume that you've done so. Irrespective of whether you knew what to solve for or not, I hope the first move was to multiply through by x plus d to cancel those out, and we're left with y times x plus d. I just wrote y in front. It doesn't matter if it's in front or behind. All right, from here, just like the previous problem, we're going to distribute. We're going to get yx plus yd equals to ax plus b. If I'm solving for x, that means I want to get all my x's on the same side, so I'm going to subtract ax from both sides. I'm going to get yx minus ax plus yd equals b, and then going to subtract yd. I don't really care what's in the back. This could be, this part right here could be as ugly as, could be the ugliest thing in the world. It could have over x times y squared or something like that. I don't care because the goal is just to get x by itself. So, to finish this question off, once more we see that we have x now in common. This was the whole point. Factor out an x. And now I've created a multiplication situation. So to finish it off, all I have to do is divide by y minus a. So x equals b minus yd over y minus a. And there's my answer. So that is it, guys. My advice to you is, if you were just watching these videos and you weren't working the problems out for the most part, now's a good time to actually rewatch the video, pause it on each problem, and try to solve it for yourself. You know the techniques. You've done this all before. The only difference here is that when we're solving, at the very end, you need to make sure that you check to make sure you're not missing a solution. Okay. With that, actually, I will say this, that, and you're not going to be asked this, but technically speaking, we could take this from the very beginning and say it has to be true that m does not equal to n, right? Because if these are this, I'm sorry, negative m does not equal n, because if that's the case, then you would end up getting this. If this was negative n, then when you substitute, you have m plus negative m, which would give you 0 in the denominator. You're not going to see that on an exam. They may state that off to the side. You'd never be asked to illustrate that, but I do want you to realize that that technically is a stipulation in these questions. All right, I've been talking too much. This is the end of the video. Hopefully I find you in the next one.